right, so today we've got Gabrielle Fundaro. Am I saying that correctly?
Yeah, that's nice
Oh,
job.
perfect. Okay, so we're going to be chatting about gut microbiome and gut health in general. So this is a topic that I find really interesting, and I think a lot of powerlifters and bodybuilders neglect this topic because it doesn't really seem to be something that big from a performance standpoint. But at the same time, you see a lot of these athletes who come, at least, athletes come to me and they'll say, hey, I'm really bloated, or I'm having, some GI distress and all these different things. So I think it's something that's really common, but it's not talked about enough in kind of the lifter sphere. And so I'm really interested to chat with you and see what you have to say. So do you mind starting out by just giving the listeners a little bit of a background, who you are, kind of what you've been involved in?
Yeah, absolutely. So I am Dr. Gabrielle Fundaro. I have my background in exercise, sport, and health ed via my bachelor's, and then I went on to get my doctorate in human nutrition, foods, and exercise from Virginia Tech. And that's how I kind of entered into the realm of gut microbiome. Although it was kind of a happy accident. It was just a serendipitous event. I started my doctoral research actually looking at the effects of high fat feeding on skeletal muscle metabolism and hypertrophy. And through a series of, like, at the time, unfortunate events, we lost a lot of the samples in my main project. But in the meantime, I picked up this little side gig looking at the potential protective effects of probiotic supplementation on that metabolic dysregulation that we saw with high fat feeding. And it happened because I was just really curious about why we were injecting mice with lipopolysaccharide and what that was supposed to sort of mimic, in terms of human physiology. And it turns out that it was mimicking something called metabolic endotoxemia. So that is this sort of low grade inflammation that is associated with leakage of this LPS or lipopolysaccharide from the intestinal tract into peripheral circulation, where it can bind to immune receptors that are located on a number of different tissues, including skeletal muscle. And I wasn't really intending on doing anything beyond, that research. It was sort of a means to an end, finish my doctorate, and then start teaching. So I was really passionate about teaching. I stayed on longer than I needed to do a whole fellowship and, like, the scholarship of teaching and learning and, behavior change and whatnot. And when I went on to work as a professor, I was working in exercise science, teaching primarily sport nutrition and anatomy and physiology and exercise science courses. And in my fourth year of teaching, I had by that point earned my CISSN, so my sport nutritionist credential through the International Society of Sport Nutrition. And I had a little bit of a blog and, like, the tiniest of social media presence, because I just wanted to, write blogs and get science out into the world that was, like, easy to digest. Haha. And Mike Israetel found me in, having I guess, a collegial debate in that Facebook group, and recruited me as a Renaissance periodization coach. So I worked as a nutrition coach with them, doing email coaching in my final year of teaching, as it turned out, because at the end of that year, I just realized that what I was looking for from my career as a professor, it wasn't really what I was getting in academia. And I was getting that much more in the realm of coaching and creating online content. And so I resigned after 4 years and went into coaching full time. And then several months after that, I started my own business, Vitamin PhD Nutrition Telehealth. And so I have two kind of very different types of coaching services that I can provide in that way. And Mike hooked me up with Steve Hall from Revive Stronger in June, I think 2017, to do my first podcast. And it was on gut health because they were like, hey, don't you, like, have a PhD in this? And I was like, oh yeah, I mean, it's, like, been a while since I did that. So that's kind of what started it. And I feel like it's been a snowball effect since then. That was like one podcast, two podcasts, three, five podcasts in 1 week. And, being able to really deliver evidence-based content around the gut microbiome and getting back to my roots with facilitating behavior change and coaching and whatnot. So that's kind of the story of me and what I'm doing now and how I got here.
Your appearance on the Revive Stronger podcast is actually how I initially became aware of you and your work. And so it's been pretty cool as well because so I've heard all the podcasts, I've read all the articles, and so it's been really cool to see that kind of like massive progression in your exposure,
Yeah.
especially because it's a really unique subject. Like I said initially, it's not something that really is covered a lot.
Hmm.
Everyone wants to talk about hypertrophy. How are you going to get stronger? How are you going to get leaner? How are you going to optimize everything else? But
Yeah.
then a lot of these adjacent variables just don't really get covered enough. And I think that that can have a really substantial impact on things like adherence, which ultimately will affect performance.
Hmm.
So I guess we'll just start out with what are some of the common issues that people experience regarding gut health, and is there a difference between less active versus more athletic populations?
Yeah, absolutely. So the irony I think here is that, if we can look at the extremes of activity, if we look at individuals who do really no physical activity, so they're far below, even the World Health Organization recommendations for, maintenance of health, and those individuals who are doing ultra endurance activities, so they're running in, extremely high ambient temperatures for hours and hours, and at relatively high intensities because they're incredibly well trained, and they can maintain 80% VO2 max for a really long period of time. That ironically, we might see um, issues with the gut microbiome in both cases. They would manifest differently. Now, what we see when we look, sort of with observational data, is that there is a difference in both the diversity, so the number of different species that we see and their relative abundance between individuals who are less physically active versus those who are more physically active versus those who are sort of at an elite level. And that the correlation seems to be with greater levels of physical activity, we tend to see more diversity, and we tend to see increases in specific groups of bacteria as well that are associated with, for example, carbohydrate breakdown. And so that makes sense that, what we're seeing is probably in part a reflection of physical activity, and then perhaps also a reflection of the diets that people who are physically active tend to eat. Whereas people who are not engaging in regular physical activity, we see less diversity. And again, that could also be a reflection of perhaps a diet that isn't as high in, whole grains and microbe accessible carbohydrates like dietary fibers. Now, if we take it out to the extremes, these extreme endurance athletes, they're quite likely to experience gastrointestinal distress. Now, when we're looking at the people who are, have low bacterial diversity, they might not have any outward signs of that occurring. We don't have really like symptoms of microbial diversity or lack thereof. Whereas individuals who are these extreme endurance athletes, they may have an incredibly diverse microbiome, but on the other hand, they're also experiencing quite often really extreme gastrointestinal distress. So there's actually exercise-induced gastrointestinal syndrome, which is characterized generally by cramps, extremely loose stool, and an urgency to go. And in some cases, people might actually like pass blood in the stool. They also, in some studies, have been shown to have higher levels of circulating LPS, or lipopolysaccharides, so that endotoxin that I mentioned earlier. They may also see increased intestinal permeability. So there's a little bit of we call it leaky gut, even though I kind of hesitate to use that term. Um, and that could indicate that maybe they're having reduced nutrient uptake and absorption, that there could be some acute potential damage or trauma to the gastrointestinal tract because of the mechanical stress of that jostling, and potentially increased acute inflammation. So we do see that inflammation is normal after an exercise bout, of course, but in these individuals, it seems that when they have higher levels of that circulating endotoxin, they more often are requiring some sort of medical intervention after that race. So they're seeing some really significant gastrointestinal distress, maybe with and we don't really know whether that's actually correlating with changes to the microbiome. Because what's interesting is that, even if we see altered intestinal permeability, we don't really see a change in the microbial profile that coincides with that. So we're not able really to identify, like, what are the changes going on here that might be causatory in the gastrointestinal distress. But it probably is something that we can manage through dietary modifications and careful nutrient timing and things like that to sort of mitigate that extreme GI distress. When it comes to resistance trained athletes, they're like, that's just like an untapped area. And I've got some stuff in the works with that, which is really exciting, but we just really don't know. Like, we don't have really any information. I think there's been one study so far that's looked at like changes in the microbiome or GI distress with resistance trained athletes, but it's just, they're not studied yet.
That's really interesting. And so I actually was speaking with Jimmy Bagley the other day, actually yesterday, and we were talking off air just about the gut microbiome and um, even shifts in, like you were saying, ultra endurance athletes to help process lactate more effectively.
Yep.
And so, to piggyback on what you were saying before, and I'm not sure if this is kind of accurate, my thought process on this. Is there somewhat of like a causative role? So, in how you adapt to become like more efficient at things like like processing lactate and things like that,
Mm-hmm.
would that potentially reach a point of actually becoming detrimental? Almost like, you're lifting weights, it's effective, but then you continue doing it, now you're overtrained.
Mm-hmm.
Does that sort of make
Um,
sense? Like in terms of how the
yeah.
microbiome adapts?
Yeah. Well, I mean, so kind of 2 points. I mean, for one thing, we're looking at living organisms that are going to um, uh, assimilate or um, the word is escaping me, process nutrients that are in their environment. Now, with that study in particular, they were looking at Veillonella is the group that was metabolizing that lactate, and the researchers actually pointed out that they didn't believe that lactate clearance was actually enhancing performance. Because they had a subsequent rodent study where they actually gave rodents propionate enemas. So these bacteria were taking the lactate that was able to actually cross from the periphery into the gut lumen, which was really interesting. That was like a new finding. This is a thing that can happen. And they were converting that to the short chain fatty acid propionate. And propionate is an energy source. And so we're taking something that, lactate normally would enter the Cori cycle, and we kind of we get rid of it, but it's expensive. It's actually, costing us some ATP, but we have to get rid of it. Otherwise we develop lactic acidosis and like, not that, it's not that it's like, oh, we're building up in our muscles and we have to like clear it out later with stretching. No, like we actually would develop a metabolic acidosis, and that would be really dangerous to us. So the Cori cycle is a really like inefficient way for us to clear lactate, and it's expensive. Whereas if we offload that job to these bacteria, now it's less costly for us, and they're creating something that actually has like more energy, because we're looking at short chain fatty acids now. And those short chain fatty acids can be taken up by our intestinal cells. Maybe they're using the propionate. Maybe it's actually being absorbed, and then it's going to be an energy substrate for the skeletal muscle cells. That part really isn't clear. But this is a phenomenon that actually is something that happens in all individuals who are ingesting microbe accessible carbohydrates in a slightly different way, in that we ferment quite a few of these dietary fibers to short chain fatty acids, thereby increasing energy harvesting of the diet. So that microbiome can potentially increase the energy availability from our diet and release that energy to us. So, of course, that has implications for endurance athletes if they're taking in a dietary carbohydrate. and, thereby taking in a large amount of dietary fiber. The estimates that I've seen have been upwards of maybe 10 to 15% increased energy harvesting. So you're taking in 2,000 calories a day, and then your microbiota are able to convert plenty of those fibers to short chain fatty acids. Maybe you're getting an extra 200 calories per day. So it could be that we're seeing this, but the substrate is different. They're just taking lactate and converting it to propionate and then increasing energy availability. And maybe, it's not necessarily that the lactate clearance is directly improving performance, but maybe indirectly through increased energy availability. So it's something that looks like it's kind of a mutual adaptation. As we engage in more and more intense exercise, we're producing a substrate for these bacteria, and then they're producing a substrate. They're creating a product that's useful for us. And so it would make sense that those would kind of correlate, that we see increased levels of Veillonella in these endurance in these elite endurance athletes. Prevotella is another one that's been noted in several studies on cyclists and rugby players. And Prevotella, Prevotella has a number of different species and strains. So we can't say like the whole group is like a bunch of good guys and we always want a bunch of Prevotella. So the activities are really strain specific, but there are quite a few strains that are associated with increased physical activity and carbohydrate metabolism. And so it could be, once again, that because they are able to, ferment fibers to short chain fatty acids, they're increasing energy availability to us.
So, what are some of the common misconceptions about gut health? I've heard everything from, lemon water and cayenne, and there's all sorts of stuff, like tea wraps and all this nonsense. And so, what are some of the main things that you see that are really obstructing people from actually improving their gut health?
Oh man, I would say that's a great way of phrasing it, obstructing people. I think that they're really, missing the forest for the trees, that they're trying to find a specific supplement, a specific probiotic. They're really worried about, artificial sweeteners. They think that they have to do some sort of like gut reset. There's certainly a lot of, this is maybe not a nice word, but I want to say like infiltration of sort of like functional medicine into this realm, and they have this sort of protocol that is not evidence based, nor is it really kind of physiologically feasible of resetting the gut, removing pathogens, and sort of re-inoculating with only beneficial bacteria. So sort of even the idea that we have one singular profile of healthy gut versus unhealthy gut, or that we have a causal link between the gut microbiome and anything else. I mean, these are hugely fallacious, but there's so much nuance, I think, in context and detail that has to go into explaining them, that those messages are just more palatable to people, and it's unfortunate that we have started to use the gut microbiome and gut health as a little bit of a scapegoat. It's like if I can't remember, like I think Food Science Babe had a meme that was like, if you want to scare people, tell them that this thing affects the gut microbiome, or like if you want to sell something, tell them that this thing affects the gut microbiome. So we can sort of use it for whatever we want because it's this very new and unknown gray area. Even the term gut health is almost lacks meaning, almost lacks useful meaning, because when we say gut, are we talking about the gut microbiome, or are we talking about the gastrointestinal tract? Because these are two separate entities. And although there's a great deal of overlap and interaction between the two, a disease of the gastrointestinal tract is not necessarily going to be caused by the gut microbiome, and changes in the gut microbiome may not necessarily be caused by that disease. We don't have that directionality yet. And then to say something like good gut health, well, now what are we talking about? What's good? Probably when we're talking about the anatomy and physiology of the GI tract, we're talking about being free of disease. Okay, that makes sense. But how do we characterize a good gut microbiome? We have some reference ranges for known pathogens, like things that definitely should not be in there. Like if you have Giardia and you're pooping water 8 times a day, okay, we can identify that and say like this is a disease state. But when we look at the profiles of healthy controls around the world, their healthy gut microbiomes look significantly different. I mean, there's almost no overlap in the way that they cluster. And then likewise, when we look at individuals who do have a disease, even even inflammatory bowel disease, they may be different from the healthy controls, but they're also different from one another. So we don't have a specific profile of like an IBD associated gut microbiome. We are starting to be able to identify specific taxa or groups of microbes that are sometimes like they generally are higher or lower than what we would see or expect to see in a healthy control. So we are starting to elucidate some of those, and we're starting to identify some keystone species. So F. prausnitzii is one that we are pretty sure should be present in all humans. And so if you have like absolutely none of it, if it's undetectable, that's unusual. So we might want to dig down into that and say like, well, why is that happening? That's a little bit strange. But the analogy that I give when we're talking about trying to determine what's going on in the microbiome as a whole, we have taken a few pieces of a jigsaw puzzle and we're starting to assemble it, and we're saying, okay, I know that some of these fit together, and based on this incomplete jigsaw puzzle, I'm trying to predict what the pieces are that are still in the box. Because even when we are identifying microbes in the gut, we have some significant limitations to even the way that we're identifying them. We're either, stuck at sort of a low resolution image of who's there, or we're looking at a high res image of who's there, but we don't really know what they're doing, and we don't know whether they're alive or dead in this fecal sample that we have. And we're also comparing to just reference ranges. So we have to have a matching barcode that we've already been able to identify. So we haven't even actually sequenced all of the microbes there. We don't have an idea, we don't have a solid idea of like the full genetic capacity of all of the microbes there. So when we say something like good gut health or bad gut health, it really is just a marketing term. Unfortunately, it's a way for people, or people are using it to describe maybe uncomfortable symptoms that they're having. And that's certainly valid. I mean, if you're having uncomfortable gastrointestinal symptoms, that's something that can be addressed either through, diet, lifestyle, or pharmaceutical means. But we don't necessarily know that that's due to changes in the gut microbiome. And the tests that we're using to, analyze the gut microbiome in terms of like the, straight to consumer tests have huge limitations. And again, we're looking at tests that aren't, they're sort of making claims that they can do things that they really can't. So they're not valid tests. So I think that's probably just that idea of having good or bad gut health is tripping a lot of people up. And the things that don't sound so sexy, but are probably the most evidence-based recommendations, like eating a diverse array of plant foods so that you can provide a variety of microbe-accessible carbohydrates. Those are like, I mean, people just can't wrap their heads around that. They're like, no, but carnivore diet. Like, I feel better when I eat a carnivore diet. And it's like, well, okay, if you feel better, that's great. I mean, I can't do much more than tell you what the evidence says thus far, and acknowledge that I potentially have biases and things like that. But it's just the basic stuff. Like you brought up, physical activity, regular physical activity, not so much, that it's potentially damaging you, unless that's your sport, that's okay. But regular physical activity and a variety of plant foods in the diet, I mean, those are two of the biggest, like the low hanging fruit that most people could implement.
That's something that I've thought about for a long time, is why do people struggle so much to accept simple advice? And I think a big part of it anyways is that you have to be consistent with it for a fairly long period of time.
Mhm.
And it's one of those things where you go in, you do it, it's not really complex, and then you just have to keep doing it and wait. Whereas if you have all of these really complicated tasks, it almost keeps your mind a little bit more engaged, so you feel
Mhm.
like you're getting more stuff done.
Yeah.
And it's just not the case at all. But I really wanted to piggyback on something that you kind of mentioned. Because there is so much diversity interindividually and cross-culturally,
Mhm.
and there isn't necessarily a really clear established healthy or unhealthy gut microbiome. I wanted to know how much of a role, or I guess what sort of role do genetics and environment play in terms of gut health? Because obviously there is a pretty substantial adaptive capacity that we have.
Mhm. Oh, I mean, I wish I had a more clear cut answer for that. In terms of sort of a hierarchy of determinants on diversity, it looks to be that geographical region is fairly significant. But the caveat to that is what goes into your region. So when we're looking at people based on their location, it's not, location doesn't exist in a vacuum. You've grown up in this area, and there are probably going to be, other, your environment plays a role, your habitual diet plays a role, the people that you're around play a role, the animals that you're around. So that seems to be, like I mentioned earlier, when we're comparing two people based on something like even their dietary. If we can put like a person in Poland and a person in the United States, we'll put them on the same type of diet. They will still cluster by region. They'll still cluster as this is an American on this diet. This is a Polish person on this diet. So it looks like region is pretty significant. In terms of genetics, it does appear, and we've seen this to a great extent in rodent studies, but we do have quite a bit of data in humans too, that we inherit at least our initial inoculation of microbes from our mother. And that is, for the initial idea was like, oh, it's, via the vaginal canal. No, it's actually because of our proximity to the rectum. So our initial inoculation is with mostly bifido. And so it's not, we don't have quite as many lactobacilli, which is the prominent group that we see in the vaginal canal. And that's different in babies who are born via C-section. They don't get that initial bloom. They are inoculated initially with microbes associated with the skin. And it's one theory behind why, individuals who are born via C-section might have like increased prevalence of asthma or allergies. So that could certainly play a role in terms of inheritance, from one generation to the next. And in rodents who are fed a fiber deficient diet, they actually lose diversity from one generation to the next. And there's a theory that might be happening in more developed countries, in westernized countries, as our dietary fiber intake has been reduced, and we're leaning more on more heavily processed foods and refined carbohydrates and things in the diet, that perhaps we're seeing this generational loss of diversity over time as well. There certainly is an interaction between our genes and our microbiome as well, in terms of our genes are the recipe book for the proteins that we can produce, and for the overall sort of like functionality of our bodies, and dictate the activity of things like our nervous system, or what receptors will be expressed in cells. And the microbiota interacts with our body cells, either directly or indirectly via peripheral messaging in some way. So our immune cells, or our immune system, also has an effect on the microbiota as well. So there's crosstalk there that we don't fully understand yet, but we are pretty aware that it's happening. So yes, there's a conversation going on there yet. It's just that we aren't able to really translate it in meaningful ways. So so I would say genetics and region play a significant role. We see that there are some microbes that are kind of specific to gender as well. So females tend to have higher levels of lactospiraceae, I want to say. So there are some gender determinants. The microbes interact with hormones, and so circulating hormone levels that might, differentiate by sex or gender could also play a role in shaping the microbiome. So thinking of what else, age. So we tend to lose diversity as we age as well. So all of those, come together to really, if we look at, inter-individual variability, as you mentioned, that explains about 2/3 of the differences that we would see in diversity. And so it's just like you as a person, and then, dietary habits, physical activity habits, the percentages kind of have changed over the years. And I think now, it might be that they have an even smaller impact really than we thought, because we're starting to have data from longitudinal studies showing that, even if we have some intervention, after several months going out to a year, the microbiome seems to rebound to its previous state. So it's like even if you kind of change your diet, if you start an exercise program, certainly if you stop those things, the microbiome will revert. But now we're finding that even if you continue those, it may still kind of get back to its baseline over time.
At least to me, that's not necessarily intuitive, that if you would continue a diet, your body would revert back.
Mm-hmm.
Um, so with regards to lifters,
Mm-hmm.
one of the big problems, especially with bodybuilders and powerlifters, are they're trying to gain weight, which means they have to eat copious amounts of food, which
Mm-hmm.
can kind of independently just be a little uncomfortable at times. And so
Yeah.
um, I'm 260 right now, and I'm going into my last dieting phase before I'm going back up. But ultimately, my end weight will be 360. And so
Wow.
just at any given time, I expect to be extremely uncomfortable. And so this is sort of a self-serving question. Do you have any recommendations from a dietary standpoint to potentially reduce maybe gas or things that are a little bit more agitating
Mm-hmm.
to your gut?
Oh gosh, yeah. Um, I would say I'll go in order of like macronutrient. I'll start with fats. Um, Obviously, fats can be a way of increasing caloric intake with very low volume. So if you're using something like an oil, you can really increase your caloric intake in a very efficient way. It doesn't take up a lot of room in the stomach. It's not going to be fermentable. Usually won't cause, significant GI distress, short of taking in, supplementing with like coconut oil before you're going to go on a run or something. That's been documented to cause some pretty loose stools. So with nutrient timing in mind, so we are biasing our fat intake away from intense exercise bouts. That's one way to increase your energy intake, with probably a fairly minimal effect on GI symptoms. That being said, when we're looking at the effects of fat intake on the microbiome, in a human study, I think it was in 2018, they fed folks a diet that was 20, 30, or 40% calories from fat. And what they found was that at 40% calories from fat, they really did see a reduction in microbial diversity in those individuals. And this actually uh, recapitulating findings that we've seen in mice, that when we feed rodents sort of the standard American diet, the westernized diet, or a high fat research diet, they're between 40 and 60% calories from fat, and largely from saturated fat. And that's really where we start to see the most deleterious effects. So probably still keeping your fat intake below 40% calories from fat is prudent based on those findings, and maybe biasing toward, and ensuring that you're getting adequate omega-3 fatty acids. We don't really know what the effects of specific fatty acid types are, because it's hard for us to look at that without seeing like changes in other variables in the diet. But looking at again, like sort of the hierarchy of influence, it looks like saturated fat, if we have that in differing amounts versus like omega-6 or omega-3s, doesn't seem to make too much of a difference compared to what we see if we change like our protein intake. So those are just the prudent recommendations. Less than 40% of your calories from fat, but fat is a really great way of increasing your caloric intake. Just make sure that you're getting plenty of omega-3 fatty acids. So then when we're looking at protein sources, protein obviously is super satiating and you don't need quite as much of it if you are bulking like mad. Again, we don't really know the effects of different protein types in humans. There have been some interesting studies in rodents where we're like, we're going to feed them 100% beef protein or 100% whey protein or 100% casein or pork. And we do see that there are some changes to some groups, like bifidobacteria seem to be really happy getting like plenty of whey protein. And so that could be, one thing that you could potentially say like, hey, a little like detail, have some whey protein regularly. But it could be that they're really actually just excited about having like lactose that's found in whey protein concentrate. So as far as protein intake, that would be, if you are lactose intolerant, then you'd need to go with a whey protein isolate or something that's non-dairy, because lactose, although it's a carbohydrate, it's not a protein, but it's found in dairy. That could cause bloating and gas and diarrhea if you're lactose intolerant. But aside from that, protein sources, there's not really, that's like gut microbiome specific. If we are talking about like plant protein sources, because many of those are associated with, increased intake of fiber and dietary carbohydrate, that might be one way of sort of feeding your microbes with some of the fiber that you might get in like beans, while also giving yourself some protein. And then with carbohydrates. So carbohydrates are going to be the primary gas formers and bloaters of the diet. So even though, of course, I'm like, yay, fiber and like a diverse array of plant matter in your diet is awesome. If you are massing and you're already getting, close to like 70 grams of fiber per day, about 70 to 100 grams seems to be sort of the range where people start to really experience GI distress. So probably staying below 70 grams of fiber per day is helpful. And that means, once you've gotten your like 5 servings of fruit and veg a day and you got half your grains or whole grains, you're probably going to be okay if you add in refined carbohydrates or things that are lower in fiber. So like cornmeal would be one, or like cream of rice, straight up rice, those things that don't have so much fiber but are really energy dense, are really carbohydrate dense. That would be another way of increasing your carbohydrate intake and sort of mitigating the GI distress that goes with that. Now, the carbohydrate types that are going to be most gas producing fall under the umbrella of FODMAP. So these are fermentable oligodimonosaccharides and polyols. So we're looking at fructose, which of course is high in plenty of fruits, lactose in dairy, fructans, which are polymers of fructose that we see in a lot of fruits and vegetables, galactic oligosaccharides, which we find in beans and legumes, and then mannitol and sorbitol, which we find in plenty of fruits and vegetables also, and then those sugar alcohols, so xylitol, sorbitol, pretty much anything that ends in an "ol" except for erythritol, which isn't fermentable. But those guys are all going to be highly fermentable. So this might be also where people might get a little bit confused, where they're like, I'm eating a really nutritious diet and my gut still feels really crappy. Maybe because they're eating a lot of FODMAPs. And it's not that there's anything wrong with their gut health or their gut microbiome. It's just that as those microbes metabolize those carbohydrates, they're either creating short chain fatty acids or gas, and we have to pass the gas. And so that can be uncomfortable. And some of those FODMAPs also have osmotic activity, so they pull water into the lumen of the intestine, and that can cause diarrhea. So like sorbitol has a pretty significant laxative effect. So if you've ever had like too much like sugar-free chocolate and then like pooped your brains out, or like sugar-free gummy bears, then that's the problem. Like your gut is doing what it's supposed to do. It's just that like the chemical properties of these carbohydrates make them a little bit tough or impossible to actually digest. So they just head on to your large intestine, and then the microbes do whatever they do, and then you're like, oh, this feels really bad. So low FODMAP diet is not intended as like a long-term diet. I don't recommend just like eating low FODMAP forever, but it is an evidence-based elimination, testing, and reintroduction process that can help you identify which carbohydrate types you tolerate better than others, and really biasing toward those.
Yeah, that makes a lot of sense. And one of the things that I really noticed as far as adherence was concerned anyways, was I was bloated all the time and I just wasn't eating a whole lot of veggies. Like
Mhm.
I'm super lazy when it comes to meal prep. So I would literally just make a massive pot of ground beef, drain it, and then have a
Mhm.
massive pot of either potatoes, rice. And then I would just eat both of it and they'd both just be plain. And I never really cared about the taste. It was just about
Mhm.
ease of effort. And so
Yeah.
I did that for a long time. And then eventually I started being like, why do I feel like shit all the time? And it was because I didn't eat vegetables for like 8 months. And so,
Oh my
yeah,
God.
oh, it was terrible. And so then I'd start eating
Oh.
more fruits and incorporating more fruits. But
Mhm.
then I found that I was really sensitive to that. And so that would
Mm.
just give me a bunch of GI distress and it would make me all bloated and I just feel like crap.
Yeah.
And so then I actually started eliminating the fruits and stopped being an idiot and was like, oh, yeah, it's because you're not eating any vegetables, you dummy. And so I started eating a bunch of vegetables and all of that, like, I think within a week or two, just completely went away and I felt amazing. I wasn't as bloated all the
Mhm.
time and wasn't retaining as
Yep.
much water. And so it's pretty crazy how much that stuff can impact, and even just your desire to eat as well, right? Like when you're having to just shovel
Mhm.
food in your mouth, it's really hard if you're, like, don't do yourselves any disservices by eating crappy and making yourself feel more bloated and just crappy than you really need to, I guess. And so that was one thing that I really got from it, was eat your veggies.
Absolutely. Yes. I've had quite a few people that have reached out and been like, I started eating vegetables again because of you. And I'm like, oh, that's awesome. And then they like feel so much better. And, yeah, there can definitely be a little bit of an adjustment period. If you like one of two things could happen. It could be that because these are living organisms that like they need nutrients, and if you're not providing adequate microbe accessible carbohydrates to them, they will either die off, which seems to be the case with bifidobacteria. Like those guys are they're just wimpy and like they're finicky and they'll just die right off. Or they will feed on the protective mucus layer of your large intestine, because that's actually a source of carbohydrates for them, and that's not probably a great thing, because that's part of like the immune defense. We've got this like bilayer of mucus that covers your intestinal cells. The top layer is inhabited by microbes, that's normal, but the bottom layer should actually be sterile. And so when they start to infiltrate that bottom layer and they get really close to your intestinal cells and start to interact with your immune cells, that could potentially be problematic. So it could be, yeah, they're dying off, they're feeding on your mucus layer, and then if they die off, then when you do ingest those fermentable carbohydrates, now they're not being metabolized by the microbes because microbes are not present. And so maybe they're just having osmotic activity and just pulling water into the gut and creating a lot of like bloating and maybe some loose stool. You just have to wait for the microbes to begin to thrive again in response to that nutrient availability. And it's also potentially that we're, if we lose a large amount of that diversity, and we're losing sort of genetic diversity as well, that maybe we're not readily we're not taking full advantage of all of the energy availability of that diet. What's really interesting to find is in germ-free rodents, so rodents that have no gut microbiome at all, they're resistant to weight gain. I mean, they have a lot of issues. I mean, they just like fail to thrive. But it really seems that the
All anyone heard
microbiome.
there was they're resistant to weight gain,
I
and they
know,
did
I
not hear
know.
any of the potential downsides.
Yes, they're going to be like, clear out my gut
Yeah,
microbiome. I don't need
exactly. Just
it.
coffee
This is the
enemas all
secret.
day.
Yeah. Yeah, yeah. So yeah, I mean, it does definitely play a role. And, there is talk about kind of, the thrifty gene in terms of, how do genetics play a role in our potential predisposition to weight gain and adiposity. And it could be that this is something similar, that we may have, some of us may have a gut microbiome that is especially thrifty and is especially adept at harvesting energy from the diet, and there are those of us that don't. And there's a recent study that Actually, one of my IG friends sent to me looking at energy excretion in the stool. So some people even, lose more energy than others in their stools. If you're losing 150 calories a day in your feces and another person is losing only 25 calories, then calories in versus calories out can be a little bit confusing sometimes. Of course, it's always just an estimate. And I'm not saying that calories don't matter. I'm just saying that we have to realize that they're estimates and they're variables we just might not be 100% aware of, and allowing for room there, that maybe the equation is not fully accurate, and that means you have to adjust based on your results.
Right. And that's one of the interesting things too, is a lot of the times, if you adopt let's just call it like a less than optimal diet, and your body doesn't just change right away. So you can get away with something for a very long time, and then all of a sudden you're like, oh my gosh, I'm having all these problems. You know what? That happened when I started drinking milk, or when and you kind of make this false correlation. And when in reality, the problem actually started potentially like several months or maybe even a year or so prior. And so it can be pretty tricky
Yeah.
to figure these things out sometimes. My sister had, or not had, has celiac disease, and she's really got it pretty bad. So to the point where if she comes in contact with like a knife that happened to be by some bread, then she has some pretty serious stomach issues, and so she's had to go very, very great lengths to prevent that. And anytime I go over, if I ever
Yeah.
cook or anything like that, like I'm washing my hands, I'm like double triple washing everything, just because and for years she went without really knowing what was going on. She kept getting mixed diagnosed, doctors didn't know what to do, and then she found out. And so it's not always clear, right off the bat what's going on. But that kind of actually brings up a couple of different things. So I'm curious, what sort of role does health, and then just also even like psychological, emotional stress, have on gut health?
Mm. Well, we know, again, there's a link. It's really interesting when we look at, effective interventions for irritable bowel syndrome. Cognitive behavioral therapy seems to be very effective. Even hypnosis. There have been, this might be biased. It's super interesting, though, that, looking at the efficacy of hypnosis versus like the low FODMAP intervention, that they actually seem to be fairly comparable. So that is compelling, to say the least. In rodent models, looking at stress, so they'll house two rodents together, and one will be, an aggressive cage mate that sort of beats up on the other one. That they do see changes in the microbiome of the rodent that has been the recipient of that abuse by its cage mate. And when we compare brain development between rodents who have been raised, germ-free, as I mentioned, with no microbiome versus those that are reared with a normal microbiome, we find that brain development is reduced or delayed or abnormal in germ-free mice, along with everything else. I mean, like I said, the microbiome plays an integral role in whole body development, the immune system, brain development. I mean, probably more than we even recognize. And that in individuals who have IBS, they quite often also have concurrently some mental health diagnosis as well. So they may have, a concurrent diagnosis of depressive disorder or anxiety. And people tend to experience GI distress when they are experiencing high emotions. Like if someone's really anxious or they're really upset, they may notice that they have a suppressed or enhanced appetite, or exacerbated GI distress. Symptoms of IBS might be worse. So there's absolutely a link. And this is something, we talk about the gut-brain axis. And again, it's an area that I think it's very new, and there are definitely some misunderstandings and things that we still need to learn. One of the big, myths that I addressed in the last couple of weeks was this idea of, gut-derived serotonin directly affecting the brain and directly affecting mood. And people will say like, oh, well, serotonin, most of the serotonin in your body is made in your gut, and this is the happy hormone. And so if your gut health is bad, then, this could affect your mood. Well, gut-derived serotonin has a number of actions in the periphery. So it is a substrate regulator. So it really regulates, what are we using for energy, especially while fasting. And it regulates gastric motility as well. But it doesn't cross the blood-brain barrier. So right now, it looks like the pool of serotonin in the brain that would modify mood is discrete from the peripheral serotonin. And we don't have evidence to show that that peripheral serotonin is what's acting in the brain. There are other neurotransmitters, and there are other conduits for communication between the gut and the brain. When we look at the gut-brain axis, most of the parasympathetic nervous system tone coming from the brain is carried on the vagus nerve, and that innervates the gastrointestinal tract. Not so much in the colon, but in other areas that can help to regulate digestion and absorption of foods. This is where we get the idea of like rest and digest. And then there are receptors that to which neurotransmitters and neurochemicals can bind in the gut, in the periphery, in the brain. And so we know that there's crosstalk. And it's bidirectional. So from the gut to the brain and vice versa. And there's an idea that perhaps, similar to that metabolic endotoxemia that I mentioned earlier, where we're talking about potential toxins from the microbiome affecting, skeletal muscle metabolism, there are theories that potentially the microbiome can be affecting mental health or brain function and inflammation within the brain as well. So I think that, once again, we have to wait for the science to kind of catch up to things, because our rodent models of mental health and of brain development are not necessarily meant to emulate exactly human development or human behavior. When we say like, looking at rodent models of even to say like mood, can we say that like mice have moods? Maybe. I mean, I'm not saying that we don't, but like, how do we identify when a mouse is feeling like happy or a sense of like ennui? I think we probably have to be a little bit more careful and say, we're talking about brain development and behavior in rodent models, looking at it from a mechanistic point of view to determine like, oh, if we see an abnormality, why might it happen? That's very different from looking at the etiology of a mental health disorder in a human. Like what did that human go through up to this point? And if we are going to try and like kind of blame it on the microbiome, I think we have to be very careful about doing that and allowing that to overshadow the many other factors that go into a human's mental health and behavior and mood, which is very different from what we would see in a rodent model. And to date, the studies that we've seen in humans trying to link the gut microbiome to mood haven't been very well controlled. So, I know a lot of attention is paid to studies looking at children with autism and like fecal microbiome transplant. But, without a control group, we have to be very careful about the conclusions that we're drawing from these studies. So that's just my kind of word of caution that, oh, absolutely, there's a link, but we just don't fully understand it yet. And we have to be really careful when we're trying to extrapolate from a rodent model of behavior to an actual human who has moods and an entire life and a frontal cortex and all of this stuff. That is going to play a significant impact and might overshadow, the role of the microbiome.
I've actually read some of those papers, especially with about the fecal transplants, and
Mm-hmm.
some of those were actually like some of my criticisms that I had as well, and where obviously I'm nowhere near as experienced in this as you are. Like I started learning about this stuff probably about a year ago. I really started diving into some of the research on it. And the more that I researched, the more that I'm like, holy crap, this is just a never ending. Like, I don't think I'll ever feel confident to ever talk about it. Like, I can read stuff on muscle fizz or I don't know, different cognitive processes. And I've written extensively on like pain science and things like that. And not to say it's not complex, because it is, but I feel like this for me is just, it's such a departure from, I guess, what I'm used to, that it's just like, holy smokes, it's so complicated. And just even the idea of trying to create a trial where you can control for all of these different variables is like, I don't even see how it's possible, you know?
Yeah. Oh, yeah,
So,
absolutely.
so it's really wild, but it's super interesting. Just kind of hearing some of the new findings that are coming out, and what that could potentially mean for I guess directing future research.
Hmm.
Um, so one of the things that I think a lot of people have concerns about, even from a dieting perspective, is uh, artificial sweeteners.
Mm-hmm.
Everyone's really worried about aspartame. Everyone's really worried about, all sorts of different things. And I found it kind of interesting that the only artificial sweetener that actually has had any sort of potentially deleterious effects has been stevia, which is the which is the organic, all natural one that everyone seems to promote because it's way healthier. And even that
Hmm.
was like, I don't believe that that's actually healthy, just based on the strength of the evidence. But I mean, it was funny
Yeah.
that that was the only one that came up. So could you just touch on, I guess, that and potentially how it interacts, so people could understand, like, from a mechanistic standpoint,
Hmm.
how it actually interacts with your body, and so we can kind of do away with some of the theories about why it's so bad for you and it causes cancer and genocide and things like that.
Oh, yeah. Um, so I think, there some of it is just the like that naturalistic fallacy, like, oh, if something's from nature, it seems like it would be like healthier and safer, and like, oh, these artificial sweeteners that are made in the lab are chemicals, and chemicals are all bad. So for something to, really have an effect on the microbiota, it has to interact with them in some way. And this is why, when we look at sugar alcohols minus erythritol, those can be potentially, like, we could consider them to be prebiotic because they're highly fermentable. So if you were to use something like sorbitol, lactitol, xylitol, mannitol, those are like excellent prebiotic nutrient sources that will give you really, really awful gas and diarrhea and bloating and stuff. So that would be like, those actually do have a measurable effect. When we're looking at, something like, and you mentioned in stevia. So stevia, and this is, again, we definitely have to wait for like far more data. But it is one that I want to say that it maybe, I can't remember which group it suppressed. Might have been bifidobacteria. I can't remember, but I know that it had like a suppressive effect. It can be metabolized by some groups. And so what might happen there is that you have groups of bacteria that can use this as a substrate, and they really thrive. And maybe either that compound directly or a byproduct of its metabolism might suppress other groups of other bacteria. So this is the case with ketones. Beta hydroxybutyrate is directly suppressive of bifidobacteria. So that could be, but it might be a substrate for other bacteria. And so we don't necessarily know, if we haven't identified like the third variable in that triad, we may incorrectly assume that like one, X is causing Y, but it's really X is causing Z and Z is causing Y, if that makes sense.
Hmm.
Now, when we look at aspartame, acesulfame K, saccharin, or sucralose, again, it's something that we actually have a fairly small number of studies that have looked at the microbiome specifically. Quite a few have looked at like gut hormones, and it looks like gut hormones, in terms of the hormones that are used to signal where we are in the digestive process and what might need to happen, those are unaffected. But the actual microbiota themselves, the microbes, also appear to be relatively unaffected, especially by aspartame. There actually been, I think, 3 or 4 human studies looking at effects on the microbiota, and it seems to be the most, uh, the least active of any of the artificial sweeteners that we could use. So that's kind of what I've decided to use. I'm like, aspartame seems like it doesn't do anything at all. I'm just going to use that one. In the early studies on sucralose, there was a lab that studied the effects in humans and then used a fecal microbiome transplant to take the responders. So there are a few humans that seem to have some changes to insulin sensitivity because they were taking in like the absolute maximum dose of sucralose each day. And they transplanted their fecal samples into rodents, and then they were able to recapitulate that. But it was very small in size. They didn't have a control group. And then a couple years later, a subsequent study that tried to replicate those findings with the control group wasn't able to. And so it was, well, again, if we don't have a control group, it's really easy to be like, oh, wow, these are really exciting findings. But we have to have something to compare it to. So again, it just, based on the evidence thus far, which is fairly limited in humans, fairly extensive in rodents, it looks like those are fairly inert. And the other word of caution that I would provide is that if we are looking at cell culture, if you want to like show something has a significant magnitude of effect, do it in cell culture. Because there are a lot of studies that in cell culture that show that like, oh, these things are really horrible for the gut, or like, oh, you can take like collagen peptides and they're super awesome for the gut. And then you like do it in a rodent model. It doesn't really do much of anything. If you do it in a human model, it does even less. So when we're using a rodent model, are we using a human, are we using a physiologically relevant dose for a human? So if we give a rodent something like 2 mg per kilogram of whatever, that's not equivalent to 2 mg per kilogram in a human. We have to plug that into a specific equation, and then we can get a human equivalent dose. So that's another sort of disconnect when we're looking at rodent models of, artificial sweeteners. So when we look at like the real human equivalent dose, looking at like the acceptable daily intake level of these sweeteners, you have to take like 65 packets of Equal a day, or drink 13 cans of diet soda a day. And if you're doing those things, then yeah, it's probably worth, maybe reducing your intake or looking at like what it is about your dietary pattern that has you, needing 13 cans of diet soda a day, and addressing those things. But, below those levels, you're probably going to be okay. And I think the irony is that like people seem to be really, really worried about like artificial sweeteners, but then they're like, I'm going to do the carnivore diet and get absolutely no fiber whatsoever. And I'm like, that's probably actually a worse idea based on the evidence. We have enough to say that that's kind of a bad idea, but who am I to tell you what to do?
Yeah, what do I know? I'm just a doctor. No, that makes a lot of sense. And it's almost like with food sensitivities as well, right? So there was a period, I'm not sure if people are still hating on dairy. I'm not sure if that's still like a thing, but I know there was a while where everyone was hating on dairy and they're like, oh, it's so bad. Look at how, how many people have sensitivities and how many people, and I was like, okay, well, there's also plenty of people who are perfectly fine with it.
Yes.
And to me, it's like an exercise, right? Like there's tons of people who, when they do a JM press, it hurts their elbows.
Mm-hmm.
Is that a bad exercise? Should we never go into elbow flexion again? It's like, well, no, like it hurts these people. So either they're doing something that's causing that exercise to hurt them, or it's just not necessarily agreeing with them, and it doesn't really matter why,
Yeah.
And so I feel like sometimes these things are really blown out of proportion, almost like I'm not sure if you've seen this. People keep sending me this on Instagram, and I just have to block them because they'll send me someone pouring a bottle of Coke on rust.
Oh,
And they're like, look what it does to the rust. And I'm like, your body's not metal. It's not rust. And like, what's the point?
wow.
Like, and then it's like, what's the point? And they're like, well, look what it's doing to this. And I'm like, okay, so what is it going to do to your body? And they're like, well, I don't know, but that can't be good. Like, come on, man. You're better than this. You're an engineer.
Oh man. It's just like, I mean, they see the same thing with like orange juice,
Yeah,
like,
yeah.
oh, but I mean, I think it's just that disconnect from like, chemistry, like knowledge of chemistry and like science class and stuff that we're never going to need to use this or know this.
Yeah, yeah.
And it's just that maybe like going through, K through 12 or, whatever educational level people have achieved, that maybe school systems aren't always doing a great job of like applying it to the real world, and like, why do you actually need to know this? Like, why does knowledge of pH matter? So that you can figure out that like, oh, the whole acid versus alkaline diet is bullshit. And, like you're not going to change your blood pH by changing, the acidity or alkalinity of your diet.
Whoa. So you're telling me if I drink a bunch of apple cider vinegar, I'm not going to live forever? Is that what I'm hearing?
Unfortunately.
Oh man,
Yeah.
that
Yeah.
sucks. Well, I just
I
wasted a
know.
lot of money at Costco then.
Yeah. Are people like taking that, to like
Yeah, yeah,
replenish their stomach acid? And I'm like,
yeah.
man, if you were drinking something as acidic as stomach acid, you would be in the hospital right now. Like
Yeah, you'd
ACV
probably
is
die.
not, Yeah. I've actually used hydrochloric acid in lab before, and like you can't even like when you open the bottle, you have to like open it a tiny bit and like under a hood with your face away, and then like use a little pipette to get it into whatever other container. I mean, that stuff is volatile. We're talking about like like your stomach acid, a pH of 1 to 2, super acidic, like drinking apple cider vinegar,
You know, it's going to
not
burn a
the
hole through
same
your
thing.
hand.
Yeah.
No, 100%. So, what are some decent heuristics for, someone who's looking to, just stay relatively healthy and do the best they can to improve their overall gut health?
hmm I mean, it is totally the basics. So, like, if you are, assuming a person is concerned about this because they have some form of GI distress, 100% I validate that, like, you're suffering right now. First step, go to the doctor. Go to your gastroenterologist or your GP. You don't have to be shy about talking about your poop. Like, tell them all about it. Tell them how often you're going, what it feels like when you're going, the kind of poop that you're having. You can look at a Bristol stool scale, and that'll help you rate the quality of your stool. Go share that with them. And then do whatever legitimate, valid diagnostic tests that they might want to do. That is not, the IgG food sensitivity test. No, not valid. Don't do that. Don't waste your $300 on that. Or the GI map test. Really interesting to get a general picture of like what microbes are in your gut. That is not a valid diagnostic test. Go to an actual gastroenterologist, get that stuff done. If you then come out with a clean bill of health, cool. If not, also good. You know what to do next. So you can go through like pharmaceutical intervention or work with some specialists that can help you with dietary interventions like an RD or whomever is in your area. Next step, if that's all clean and you're still having some GI distress, there are evidence-based or systematic ways of determining what your GI or what your food intolerances might be. So an intolerance is lack of a digestive enzyme, or you may have a food allergy. So you could potentially go to an allergist and get screened for that. But again, they're not really going to be able to diagnose you. If you try something like the FODMAP process, again, that's not a long-term diet. That is a system of elimination testing and reintroduction that's done in a systematic and specific way to help you identify what foods you can tolerate or not. So that's if you're having issues. There are also some like exercise specific considerations. I usually recommend limiting the F's, so fat and fiber. So those are the things that you probably don't want to have, and FODMAPs. So fat, fiber, FODMAPs. Of course, like fiber falls under FODMAPs, but FODMAPs can also be like lactose. So make sure that you're not having those, in the few hours before your workout. That's probably going to help to mitigate some of the GI distress. Now, if you're not having issues and you're just kind of like, hey, I just want to make sure that like I'm feeding my microbes, that's awesome too. Aim for a diverse plant centric diet. You don't have to be vegan or vegetarian. In fact, we don't have a specific vegan or vegetarian style microbiome. Vegans are quite diverse, and so are vegetarians, and so are omnivores. So you can still have animal, sources in your diet. That's totally fine. But the number that we have right now, based on the American Gut Project, which is sort of like a citizen sourced science project, which is really cool, is 30 different plants per week. And that doesn't have to be just vegetables. It's fruits, vegetables, legumes, grains. So anything that's a plant, just try and eat plants with every meal. That's what I say. So I like eat vegetables with every meal and or fruit and or a grain. So plants at every meal. Um, as I mentioned earlier, trying to maintain that less than 40% of your calories coming from fat and getting regular physical activity. Those seem to be some of the best determinants of diversity in humans, is looking at the amount and diversity of microbe accessible carbohydrates, the amount of physical activity, and then the contribution of fat to caloric intake in the diet. Those are probably the big three that I would say, like, if you have those down, there's really no reason to believe that there's like anything wrong with your gut microbiome.
One thing you just kind of mentioned really briefly was looking at pharmaceutical intervention. So I
Mhm.
think for people who are currently taking pharmaceuticals or who are worried about potential damage that can come from taking pharmaceuticals, what sort of impact can that have on your gut health? And then I guess would the strategies be the same to kind of rebuild it?
Yeah. The two pharmaceutical or OTC drugs that have shown to have the most significant effect, or classes of drugs that have shown the most significant effect on the gut microbiome, would be metformin and antacids. Um, Most folks with metformin do experience pretty significant GI distress. And there is actually some evidence that part of the mechanism of action that makes metformin effective is that it modifies the gut microbiome. We see some similar effects in individuals who have bariatric surgery, and have significant changes to the anatomy of the gastrointestinal tract. And in those individuals, if they have like a type 2 diabetes or insulin resistance, that is almost entirely reversed with alarming speed after bariatric surgery, potentially also because of changes to the gut microbiome. Then with antacids, because we're potentially changing the pH or the acidity of the duodenum, which is the first part of the small intestine that's connected to the stomach, that we may be giving rise to groups of bacteria that wouldn't normally be there, because acid is one way to control microbial growth. So if we have less acidity, we have greater microbial growth. And so that's also been shown to have a significant impact on the profile of the gut microbiome. We don't know necessarily what clinical outcomes that might lead to, but it looks like people who are using antacids long term may be in sort of a risk group of for small intestinal bacterial overgrowth, or SIBO, where we're getting bacteria in the small intestine that really are not supposed to be there. I know probably a lot of people are also thinking about antibiotics, and the effect of antibiotics on the gut microbiome are highly variable because it really depends on the type of the antibiotic. Some of them are very specific. Some of them are really broad spectrum. They're going to have different strengths, different lengths of the dose. And so we might see that the effects of taking a very basic antibiotic might be, that we go back to normal within a few weeks. If you've been on something significant like a vancomycin or something, you've had a severe gastrointestinal infection along with that, it may be months, maybe years, and things don't, go quite back to the way they were before. And then people, I think, are usually curious about probiotic supplementation as well. Probiotic supplementation, the effects are strain specific and they're fairly limited. So if you have something like diarrhea associated with antibiotics or traveling, some strains of probiotics might be helpful for reducing those symptoms. Same thing with constipation or inflammatory bowel disease. But again, you'd really need to take the specific probiotic for whatever your issue is. And we don't have a great range or we don't have a great, reference for like how big the dose needs to be or how long you need to take it because studies are so heterogeneous that it's like, oh, these people took 2 billion CFUs for 3 weeks and these other people took 10 billion CFUs for 6 weeks and seemed to get pretty much the same results or totally different results. And now we can't, aggregate this data. So that's kind of where we are with probiotic supplementation. And then, with other pharmaceutical or OTC drugs, they may have an effect, and it may be that the microbiome interacts with them in some way to make them more or less effective. Individuals who are taking cancer treatment drugs, probiotic supplementation is actually contraindicated because there's an interaction there. So we just have to be really careful, with kind of what we're taking and, disclose that to our doctor and whatnot. And then, not assume that like all probiotics are just going to be good for gut health. And it's like a kitchen sink kind of, multivitamin, because that's definitely not the case.
Right. So regarding probiotics,
Mm-hmm.
one of the things that I've been interested in is whether or not they're actually like efficacious when they come to market, right? So there's
Mm-hmm.
obviously a difference between what they're using in research versus what you can just buy over the counter. And so do you know, or is there any sort of like research on either the quality or the actual like concentration
Mm. Well, so when they are, obviously anything that's marketed as a supplement, that might have third party, well, at least in the US. So in the US, the DSHEA Act was put into law in 1994. And that is what regulates nutrient or supplement claims, along with the FTC, the Federal Trade Commission.
Is that
The
considered a
FDA,
supplement?
probiotics.
Yeah.
Yeah.
Okay.
Yeah, in the US. Now, there are some that are considered like a medical food, which might be
Yeah.
regulated a little bit differently. But yeah, what you're getting over the counter here, it's just a supplement. So the FDA is really only retroactively involved. So if someone like gets really sick and dies from probiotic supplementation, then they might say like, okay, we're going to ban probiotics, like they did with ephedra here. The FTC regulates claims. So if someone says like probiotics, this probiotic cures inflammatory bowel disease, FTC would be like, no, 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 you can't make that claim. You can't claim to treat, cure, prevent any disease. You can claim to like maintain normal function. So you can say something like supports healthy immune system, because that's kind of like a meaningless term. And it has to also be supported by literature, but it's the manufacturer who gets to provide that literature. They can be like, oh, hey, here's this study on like this one strain of probiotics or this one strain of bacteria and how it interacted with like some immune cells in the gut. And so we can say that it supports a healthy immune system. And it's like, okay, sure. And if this existed before 1994, you just basically have to like send a letter to the FDA saying like, hey, we're going to put this on the market. And FDA is like, okay, cool. It's not actually FDA approved. And it says that on the label. These statements have not been approved by the FDA. Now, the manufacturers don't have to show like any proof of the purity or concentration of their product. They can get third-party testing. So a third-party lab, like we've got like USP, and I think, and I can't remember, there's another one, but there's like a USP label that shows like this has been third-party tested for purity and dose, but not efficacy and not safety. So if you get something that has that label, then you know, okay, like at the time of manufacturing, this had 5 billion CFUs or colony forming units. But if it's been sitting on the shelf for 2 years, then there's no guarantee that like you'll still have that amount. And if it's past the expiration date, definitely no guarantee. Now, we don't necessarily, the microbes, those probiotic microbes don't necessarily have to be alive to exert an effect. We don't really know the mechanisms. And we don't have a lot of data on like what's happening with those microbes that we're ingesting when they're actually in our bodies. We have a lot of, okay, you take this probiotic, now how do you feel? And now we're going to look at your poop. And what will happen is that those bacteria will go from mouth to poop without necessarily enriching on the way through. And there actually have been a couple interesting studies looking at that some individuals seem to be fairly resistant to probiotic enrichment, and other individuals seem so heavily enriched by these probiotics that it actually causes something of a dysbiosis, a disruption in the normal levels that we would see, the normal relative abundance. And then, like I said, they might go through and in one end and out the other. They may still have some effect transiently on gene expression of other microbes there. Or if they go in and they're dead, they still could potentially have an effect on the activity of the surrounding microbes, because even a dead microbe will have chemical signals indicating like who it is. And so that could still potentially influence the activity of other microbes. But our poop just doesn't really tell us a whole lot, because it's like, we don't know what actually went on in there. It's like whatever happened in Vegas stays in Vegas, and you just come out the other end.
One of the questions that I always like to ask everyone who appears on the show is, what's one opinion that's maybe a little bit more anecdotal, maybe goes against the grain a little bit, but it's something you feel confident enough to kind of put your name on, at least for the time being, based on the available information?
Gosh, I am like, I feel like I try to be extremely cautious in my statements, and like measured and prudent in what I say. I've even softened a little bit on my stances on the carnivore diet. But I'm fairly confident, and I don't even know that this goes against the grain, except for like the carnivore people. I'm fairly confident in saying that the carnivore diet probably has significant deleterious effects on the diversity of the gut microbiome, both in terms of taxonomic, like who's there, and function, and that probably also leads to some thinning of the mucus layer, and that probably when people are trying to like reintegrate foods back in and they're using that as their confirmation bias for like why they can't eat fruits and vegetables, that it is really either that they're just eating a lot of FODMAPs and they don't know it, or that their long-term adherence to the carnivore diet has left them in a bad way, and they're lacking that functional diversity that they really need to be able to process those foods well. So that's I don't know how controversial that is, but that's as bold of a statement as I want to make.
Awesome. Well, thanks for tagging the carnivore. I'm going to have to officially shut down my podcast and move again. No, and I mean, I think that kind of makes sense. I feel like anytime you go to really any extreme, you're probably going to experience something pretty significant in terms of a change. And I just can't see a rationale to not include vegetables and fruits in your diet. So, yeah. But I mean, I don't know. I've never really tried it, but I just don't think that I'd last more than the day, to be honest. I think I'd be way too hungry.
Yeah, for real.
Yeah. Well, Gabrielle, that was really interesting conversation. I feel like we covered quite a few different topics. So thanks so much for jumping on the show today. Is there anywhere where the listeners can actually find you?
Yeah, absolutely. So Instagram and Facebook at Vitamin PhD. I have a website, actually two websites now. So vitaminphdnutrition.com. And then if you want to check out the other work that I'm doing with Shannon Beer and Dan Feldman, our Bridging the Gap and Comprehensive Coaching Series, we're going to be putting on a series of webinars in September and October where we're talking about our approach to coaching. We take an agnostic view of nutrition and weight management. And we like to kind of talk about those gray, weird areas and bridging the gap between a bunch of different aspects within the industry. That's at btgcomprehensivecoaching.com. And you can find that in the link on my Instagram profile as well.
Awesome. Yeah, so all that stuff's going to be linked up in the show notes, guys. Definitely go check her out. Give her a follow. She's always posting really, really great stuff and puts out lots of good content. I think I've probably seen at least 3 or 4 of your lectures at different summits and things like that. So some pretty cool. Hopefully once the travel ban is up, I'll be able to fly a little bit more to different events and things like that. So looking forward to that. But yeah, thanks so much.
Yeah, thank you for having me.
Guys, thanks so much for listening. I hope you enjoyed the episode and took a lot from it that you can apply to your own situation to see much better results. I just have one quick personal favor to ask of you. Please make sure you subscribe and leave me a 5-star rating on whatever podcast platform you're using. When you do this, it helps me get better at producing content and increases my exposure so I can continue putting out high quality information for you guys. Next, I want to extend a personal invitation to shoot me a DM on Instagram at Stacked Strength. I'll help you troubleshoot anything you need. This is literally an invitation to connect with me directly, so make sure you head on over and jump into my DMs. All right, guys, thanks so much for listening, and I'll see you next time.